Hello, dear students. Welcome back to my YouTube channel. Good evening to all of you. I guess I am audible and visible to all of you. Hello, hello, hello. Hello, dear students. Welcome back. Yes, I am audible. Asta Goyal, beta. Good evening, beta. So, as you know that we have started NLM, right? Yesterday was first lecture on this NLM. Today we will be having a second lecture of NLM, and in this lecture we will try to finish Newton's second law of motion. Done? And in the morning classes we started electrostatic in English. So there we concluded some topics. So same, na? Morning we will be having one session for electrostatic English, and evening we will be having NLM in English. Okay. If you are having any suggestion or if you are having any issue or any doubts, you can let me know here. Be consistent if you want some good change in your preparation. Good evening, beta. One second, I am just setting up these things. Done. Okay. Okay. So I guess my board is visible to you now. I hope my this particular board is visible to you. Let me know. Okay. Okay. One second. Hey, let me just fix it. Okay. So in yesterday's class, if you were present in yesterday's class, we completed certain topics. We completed what is law of inertia or first law of motion, what is of if f net is 0. These things we discussed in yesterday class, and we discussed about inertia, types of inertia, a change in momentum. These things we discussed in yesterday's class, and we discussed some characters as well. Am I lagging? Am I lagging? Let's just fix it now. I need to fix this lagging because it will put a bad impression. Nice, good, no? Hello, hello, 1 second. Hello. Is it okay now? No lagging now? Give me 1 second now. I will do whole things, right? Give me 1 second. Now I guess there is no lagging now. Yes? I hope there is no lagging now. Due to rain, I guess this lagging is happening now. Okay, you can bear with these things, okay? Just a little bit of okay. Look now. So in this particular class, we are going to start. Okay, so we will start here. Newton's second law of motion. Newton's second law of motion. Take. And second state is that rate of change of momentum of any body is dependent the external force. Done. Rate of change of momentum of any system is proportional to the applied unbalanced external force. I will just I will repeat it. Rate of change of momentum of any system is directly proportional to the applied external unbalanced force. Done? So look, we are having force. Force are two types. One force is known as average force. One force is average force. One force is instantaneous force. Instantaneous force. Done? For average force, we will write here delta P by delta T. For average force. But if we want for instantaneous force, I can write F equals to dP by dt. I can write like this now. But do you know what is momentum? Momentum is mass into velocity, and we done it in last class. Okay, so how I can write it? I will write it like F equals to d divided by dt mv. We can apply chain rule here. So I can take m dv by dt plus v dm by dt. By chain rule, now here I can take more two steps. If my mass is constant, one step is if my mass is constant. Second one, if my velocity is constant. If my mass is constant, so this term will become 0 then. So I can write my F is equals to m dv by dt. Or I can write it like m into a. I can write m into a. I can write m into a. But if my velocity is constant, so this term will become 0 now. So for second one, I can write F equals to V dm by dt. Okay. So what you need to learn from this particular slide, that's Newton's second law of motion state, is that rate of change of momentum is directly proportional to the applied external unbalanced force. If my force is average, I can write delta p by delta t. If my force is instantaneous, I can write dp by dt. Now I will elaborate p as m into v. I will apply the chain rule. It will become m dv by dt plus v dm by dt. If my mass is constant, so I can write m into a. If my velocity is constant, I can write v dm by dt. That means mass is variable. Done? So what you need to learn from this particular slide, that is my force is equals to dp by dt. This should be your things, right? You can write F equals to delta p by delta t. Second equation. You can use F equals to m into a. Third equation. You can use F equals to v dm by dt. These are four equations. This equation is general equation. This one is general. This one is for average force. This one is when my what? When my m is constant. When my mass is constant. When my v is variable. When my v is variable. This one when v is constant. Is constant and m is variable. Okay. I guess this slide is very crystal clear to you. There shouldn't be any kind of issue with. Okay. So what I will write here, when a very large force acts on an object for a very short time interval, then product of this force and time is known as impulse. Is known as impulse. Okay, this is a proper definition that you need to write down if somebody will ask you what is impulse. Large amount of force acts for a very small time interval. So the multiplication of this force with the time is known as impulse. Is known as impulse. Force multiplied by time. Okay, I guess I can write force. Is it dp by dt? If I multiply force, I can take dt here, right? So delta p is equal to f delta t. So from this particular equation, force multiplied by time is momentum and force multiplied by time is also impulse. Okay, what do you need to learn here? That force multiplied by time is momentum also. Force multiplied by time is impulse also here. But what is the difference between impulse and momentum here? Is for very short period of time and momentum is not for very short period of time. So I can write here impulse is equals to change in momentum. Impulse is equals to change in momentum. Done. And this particular thing is known as impulse momentum theorem. Impulse momentum theorem or theory. Impulse momentum theory. And what is F average? So I can write F average. F average is delta P by delta T. Okay. So here I can write delta P is equals to F average delta T. F average delta T. Now we are having three different ways to calculate impulse. Three different ways. First one, impulse is equals to M V final minus V initial. Second one, if my force is constant, I can write impulse is equals to force average delta T. I can write while my force is constant. For constant force, I can use this equation. Third one, impulse is equals to integrate F dt. This one we can use when my force is variable. Okay, if my force is variable, I can write integration of force into delta t. If my force is constant, I can write force into delta t. If there is anything about velocities, I can write m v final minus v initial. Okay, so here from, if I just make a graph now, okay, a graph now. Look now, this is my graph between T and P, and we are having any curve here. I will take a tangent to this particular point, this theta. So I can write, look what we know now, that force is equals to dp by dt, and dp by dt is my slope. Okay, and it is equals to tan theta. That simply indicates the slope of PT curve. The slope of PT curve gives me force. Slope of PT curve gives me what? Force. And one more thing, if now we are having force and time, and we are having any equation like this, no? any graph like this, we know that impulse is to integrate F dt. This thing is area under curve. That means area under T curve. Area under FT curve gives me impulse. Area under FT curve gives me impulse, and slope of PT curve gives me force. these two things you need to remember. You need to remember. And you must be aware of cricket, right? You must be aware of cricket. In cricket, what we are observing now, in cricket, what we are observing that when a person wants to take a catch, when a person wants to catch the ball, the person takes his hand or her hand backwards. You note these things, right? That's why I am playing a cricket, I'm a player, and a ball comes towards me. I am raising my hands to catch the ball, but I am not taking the ball. It is I am taking my hand backwards. I am taking my hand backwards. Why? I am increasing the timing. I am increasing the timing. So what will happen here now? Look, mass is same, mass of ball is same before hitting my hand and in the air. Velocity is same. So I can write my momentum change is same. If my momentum is same, so I can write impulse is same. Impulse is, so I take my hand like this, I can take my back, my impulse is same. Change momentum of the ball is same. So what will be there now? We know that force is, or average force is equals to delta P by delta T. This one is constant, right? So my force average is inversely proportional to my delta T. If we increase the timing, it will reduce the force. If we increase the timing, it will reduce the force. So the chance of getting hurt gets reduced. That's why a player takes his hand or her hand backwards. Okay, to minimize the chance of injury. Why? By increasing the timing. Done? Okay. Let us do a numerical now. Let us start a numerical for this particular topic. If my force is equals to 6t square plus 2t, what we want to take out, and we have to find out impulse. I need to find out impulse between t equals to 0 to t equals to 3 seconds. I need to find out impulse between these time intervals. Okay, look here. As we can see, the force is not constant, it is variable. Force is variable, it is time depending force. This one is time depending force. If force is time depending, which formula should I use now? Which formula? Force variable, so I can use formula. Okay, that is I need to integrate it. So if I need to get my impulse, I need integration of f with respect to dt, and my limits are 0 to 3. I can f is 6t square plus 2t. Integrate the whole thing with respect to dt. Take the limits as 0 and 3. Integration of 6t square will be 6t cube by 3. 2t will be 2t square by 2. Limits are 3, 0. Now 3 1 are 3, 3 to 6. 2 1 are 2 cancel out. So we are having now 2t cube plus t square, upper limit 3, lower 0. So we are having 2, 3 cube plus 3 square. Okay. So what we are having now? 2 multiplied by 27 is 9. 54 plus 9, 63. So my answer came out to be 63 Newton second. Easy? Done? Now, one more numerical. I will write down now the whole numerical, so that you will get an idea about the numerical, how numerical looks like and how you need to manipulate the values. A hammer. A hammer. One second, beta. A hammer of mass 5 kilogram is moving. A hammer of mass 5 kilogram is moving with speed 10 meters per second and stops when stuck with the wall. Stuck with the wall. With the wall. If contact time is 0.2 second, then find impulse, second, average force. These two things we need to calculate. So first of all, we need to decode the whole thing now. How, sir? Look, beta. Hammer of mass 5 kilogram. So what is given to us, sir? Mass given to us 5 kilogram. Okay. Speed. Initial speed is this much. I can write, sir, initial speed, it is equal to 10 meters per second. And stops when stuck with the wall. So final speed is given as 0 meters per second. If the contact time means delta t, if delta t equals to 0.2 second, what is impulse? So we are having couple of formulas, right? So I will show you. We are having couple of formulas for impulse. Look, we are having couple of formulas. Where impulse goes? One second. Look, so we are having one formula now. You can see this formula. This formula is all about mass and velocity. So I can use this formula. So this formula is equals to impulse is equals to m v final minus v initial. What is m? 5. V final is 0. V initial is 10. I guess my answer came out to be minus 50 kilogram meter per second. My first answer is minus 50 kilogram meter per second. Now second question is I need to find out what average force. I guess my average force is equals to change in momentum divided by delta t. Change in momentum is also equals to impulse by delta t. What is this impulse? Is it 50? Yes, sir, 50. And it is 0.2. So I can write it is 50 divided by 2 multiplied by 10, which came out to be 250 Newton. Yes, my answer is 250 Newton. And we are having one more student here. Arca Lord. Yes, beta, you are correct. 250 Newton. That means we completed one numerical based on the integration one if my force is variable. We done second numerical based on F delta V formula and F average. Now let us having a third numerical which is based on the slope. Okay, we will be doing all the possible numericals. So numerical is like that. For the given PT graph, find a ratio of forces on particle A and B. So first of all, let me just make a diagram or simply a graph, one graph. I will make here two graphs, right? Two graphs, so that you will get a better understanding of it. Two graphs. And the graph is PT graph. PT, right? A, B. This angle is 30 degree. This angle is 30 degree. This angle is 30 degree. This angle is equals to 45 degree. A and B. So what do we need to find out? Ratios of forces. Okay. So you must know that the slope of PT graph gives us force. Slope of PT graph gives us force. So here I need to find out forces of A and B, then divide these two things, right? Look now here. First of all, I will take first object, right? Tan theta. It is for A object. For A object, I will write tan theta. It is tan how much? Tan 30 degree equals to force of A. What is the value of tan theta? 3:1. Look now. So what is force of A? So tan theta. What is tan theta? 1 by root 3. Done? Okay. For B now, for B, FB equals to tan theta. What is theta? Theta means this angle. It is 60 degree. This one is 60 degree. And tan 60 is root 3. So can I write now tan 30 degree divided by tan 60 gives my force of A divided by force of B equals to 1 divided by root 3 whole divided by root 3. It came out to be 1 by 3. It is 1 by 3 beta. Second one now, this case. So I can write here force of A. Force of A equals to tan theta, tan 30 degree, and tan 30 is 1 by root 2. Sorry, 1 by root 3. Done. For B, this angle is, look, the whole angle is 90. So this angle came out to be 45 degree. So what is force on B? It is tan 45. What is tan 45? That is 1. So I can write here force on A divided by force on B. It came out to be 1 by root 3. 1 by root 3. No worries, beta. Okay, let us do one last numerical. T. This one is P. A, B. This angle is 30 degree. This one angle is 15 degree. Give me FA and FB. A ratio of FA and FB. I am waiting for your response now. Okay? I am waiting for your response now. Take your time now. Don't be in hurry, right? Take your time. If you have not done it before, take your time. Don't be in hurry. But Arkalar, why you are in a hurry, right? It seems to be you are not just taking these numericals, no? You are just doing, take your time, right? Take your time. I will give you a hint. Look now. If this angle is 30 degree, so this angle would be close to how much? 60. If this is 60, this would be 45 degree. Okay. So for A, it is tan theta. I can write here tan 45 degree. This could be tan 60 degree. Done. Tan 45 is 1. Tan 60 is root 3. So my answer is 1 by root 3. My answer is 1 by root 3. Done. Easy now. Just because you are not taking these numericals on a serious note, right? Because you are thinking, oh, 15, 40 to 45 in 45. It is not like that. Take your time, and think about where from I need to measure the angles. Okay. Now, different types of numericals now. We are done with 4 types. Now fifth type. Now fifth type, for the variation of force with time shown in figure. Okay, this time I need a very crystal clear concept from your end. First thing, find out impulse from t equals to 0 to t equals to 0.6 seconds. Second one, if initial momentum is 20 kilogram meter per second, what will be final momentum? And my graph is like this: T F. This is my graph: 0.6, 0.2, 0, and 200. Done? Okay. So first of all, we need to think that which concept we need to put here. Okay. If we are having force time graph, so the area under the curve will give me impulse. So the area under the curve will give me the impulse. Done? So I will write here, sir, formula for impulse is equals to integrate of f dt. It is area under curve. This one is area under curve. What will be area? So for first one, impulse, what is area? It is triangle, no? 1 by 2 base. Base is 0.6. In height is 200. Is it 60 now? Yeah, 60. Is it 60 kilogram meter per second? Okay, it is 60 kilogram meter per second. Okay, second part, impulse is equals to final momentum minus initial momentum. I need to find out final momentum. So final momentum is equals to impulse plus initial momentum. Impulse is 60, initial momentum is 20. So I can write here my final momentum is 80 kilogram meter per second. Final momentum. This one is my initial momentum. Clear? 80. Perfect. Clear, beta? Clear? Easy? Okay. One more numerical. At 2 equals to 2 second, at time equals to 2 second, if mass is equals to 2 kilogram, what we need to find out? We need to find out impulse. T and x. X is in meters, T is in seconds, right? This is my graph. 240, 0. I need what? I need impulse. And I will wait for a couple of minutes so that I will check your answers. We are having an x and t graph. Look, this graph is not between f and t. This is x and t. We need to find out impulse at 2 seconds. Then how we can do it, no? Easy? So we are having couple of formulas. Which formula we can use? Impulse m v final minus v initial, or f average delta t, or integration of f dt. Yes, perfect, perfect. Look now, I can think my impulse is equals to m v final minus v initial. Okay, m is 2 kilo. Finally your particle is at rest, right? So you can use here tan theta. It is tan theta. Okay, so you can use now. It is 0 here. It is 0 here, no? I can write it came out to be slope. Slope is 0. Slope is 0. So my velocity is 0. Finally, it is at rest 0. Done? Initially. Initially means this slope. This slope, no? It is constant slope. So what will be the slope of this one? Slope is it 40 by 2, which came out to be 20. So my initial velocity gives out to be 20. So it is 20. So my impulse came out to be minus 40 kilogram meter per second. Yes or no? Then easy beta? Easy or super easy? Easy, no? Okay. Now, different set of numericals now. Because we need to do all, no? No, beta, it is, look here. Basically, na, graph is between x and t, no? If we are having f and t, so the graph of f and t, this area will give us impulse. This area will give us impulse. Okay. So here you can see it is xt graph. It is xt graph. So xt graph will give us velocity. So not graph, it is graph will give us nothing, right? It is area. Area is not defined. It is slope is only defined. Slope. And slope gives us velocity. Slope gives us velocity. So we can approach like this. Okay. Yes, xt graph gives velocity. And area of xt graph is not defined. Yes. Okay. Now different numerical. Now if my momentum is p equals to 5t square plus 10t plus 20. Find force at t equals to 2 seconds. Find force at t equals to 2 seconds. I will give you 2 minutes so that you can do this numerical. I am going to give you 2 minutes, right? So here we are having timer, right? So I am going to give you here. Take your time. Give me the answer. Think about how to get force from momentum. Think about it. Take your time now. Okay, so as I didn't get any response from your end, so I think that you are not able to do this numerical. Okay, so we need to get force if we need to calculate the force if my momentum is given. I guess we are having the law, na second law, that force is equals to dp by dt. This is my second law. So I can apply the second law to get my answer. 15. Okay, I will show you the answer. Now then you can tell your answers. Okay, look, I can use force is equals to differentiation of P. Is it like this now? Yes, sir. So differentiation of 5t square will be 5. T square is 2t only. 10, it will be 10 only. Then 0. I can write 5 to the 10. It is 10t plus 10. It is my force. But I need force specifically when t equals to 2 seconds. I can write 10 into 2 plus 10. It is 20 plus 10. It is 30. 30 Newton. So my answer came out to be 30 Newton. Okay, beta? Easy or super easy? I guess this numerical is super easy, right? You can tag it as a super easy. Important as well and super easy as well. Okay? Let's do an important numerical and a good one. A good one numerical now. Good one in the way that my momentum is in a vector form, that means 10 sine 2t I cap plus 10 cos 2t j cap. First of all, calculate magnitude. Calculate magnitude of force at NEET. Calculate magnitude of force at NEET. Okay, so P is given. We need to find F. We can use second law. F equals to dP by dt. Okay, we can use that thing now. Look here. I can use here F equals to dP by dt. So I can write d by dt. So we are having 10 sine 2t I cap plus 10 cos 2t j cap. Done? Okay. 10 I will take outside. Differentiation of sine 2t equals to sine 2t is cos 2t. And differentiation of 2t will be 2 only. 2. And we are having I cap. Minus 10 is 10. Differentiation of cos will be minus. That means I put here minus. I can write here sine 2t and differentiation of 2t is 2 only, then j cap. I can write here 20 cos 2t I cap minus 20 sine 2t j cap. This one is in vector form. I need it is magnitude only, so I can take it small. It came out to be 20 cos 2t whole square plus but we are not considering motion type here, right? We are not taking a motion type here, right? It is sine here and it is cos here. So we cannot comment on it, right? It is 20. Now we are having sine 2t square and then root. 20 square, I can take 20 common. It is 20 square. Then we are having sine 2t square plus cos 2t square. Then sine a cos sine square a cos square a, it is 1. So based on this particular thing, I can write F came out to be 20 Newton only. Okay, based on this thing, I can write here. Look, we know now sine square a plus cos square a, right? It is 1. So based on this thing, I can write here 1, and 20 square is 20 only. But if somebody will ask you, what should be the angle? What should be the angle between momentum and force? What is angle between momentum of force? If you want to find angle, so for angle we know we need to apply dot product. For angle we need to apply dot product. Why? Because a vector dot b vector equals to a vector mod, then b vector mod, then cos theta. So I can write cos theta is equals to a vector dot b. A is momentum, I can write momentum, dot b is force, I can write force, divided by momentum vector mod and force vector mod. I can write like this now. Yes, 90 is correct. Prabir, you are correct, beta. Okay. So P into B, cos theta, P. What is P? P is 10 sin 2ti, 10 cos 2tj. Okay. And what is F? F is 20. So 20 into 10, that is 200. So I can write 200 sin 2t. Then what we are having? Cos 2t, then we are having cos 2t minus 200 sin 2t, then cos 2t, whole divided by P and F. P and F, right? So what is P? What is P magnitude? No? We can do one thing. Now we can do one thing. I can write P and F as it is. P and F as it is, right? Why? Because these two get cancelled out. So my cos theta came out to be here 0 degree. And it is only available that when theta is 90 degree, so my cos theta be 0 degree. That means the angle between my momentum and my force is 90 degree. Is 90 degree. Apurva beta. Apurva, no? Beta, I was not aware of your name, no? Because your name was written as Prabir. That's why I call you Prabir, right? Don't take me otherwise, right? Okay. So my angle came out to be 90 degree. Okay. Look, this only up to this particular thing. Up to this particular thing, we are applying my second law. Now, apart from these things, we are applying basic maths, right? This is basic math. This is vector. And this concept is from vectors, right? Vectors. So that's why each and every teacher is telling to every student, beta, make your basic strong, make your base strong, your units and dimensions, your basic maths, your vectors. That's why. The reason is this one. Done, beta? Clear? Okay, let us do a good numerical now. Good numerical now. Okay. Numerical is, we are having a bat. It's my bat. A bowler throws the bat towards my bat. Okay. It gets reflected by 90 degree. It gets reflected by 90 degree. Done. And my velocity is 15 meters per second. And my mass is equal to 2 kilogram. Find my F average. What will be my F average? A bowler throws the ball in such a way that after striking the bat, it gets reflected by 90 degree. It gets reflected or deflected by 90 degree. What will be the force average? What will be the force average? Okay. So can I write here force average is equal to delta P by delta T? In yesterday's class, we know that if any angle is there And if the angle is with the horizontal, this would be 45 degree. So theta is 45 degree. So what is change in momentum? Perfectly, it is 2 mv cos theta and delta t. Delta t is, let us suppose, 0.2. Suppose. So I can write 2. 2 is 2. M is how much? 2. V is 15. Then we're having cos 45. Delta t is 0.2. So what will be the answer now? What will be the answer now? Huh? Give me the answer, beta. Give me the answer. Answer for this numerical. I can take 0 out. I can write here 10. Okay. 15, 2 to cancel out. So I can have 300. It is 300 divided by root 2, right? So I guess it came out to be root 2 equals to 0.7 something. It is 210 something Newton, right? So my answer came out to be approximately 210 Newton. Done? Any issue with this numerical now? (300 root 2). Yeah, that is correct. No, 300 root 2. Yeah, beta. It is 300 root 2, not 150 by root 2. Okay, now look. Next topic is calculation. Calculation of average force. Calculation of average force. Look now. If this is my wall, and we are throwing a ball with mass m and velocity v towards this wall, and it gets stuck, and this ball gets stuck towards the wall. Okay, we are throwing the ball towards the wall and it gets stuck towards the wall. That means my final velocity becomes 0. So what is impulse now? So impulse is equals to mass v final minus v initial. V final minus v initial. So I can write I, mass is m, v final is 0, minus v initial is v I cap. Okay, so my impulse came out to be minus mv I cap. If you need to write it is magnitude, so it is more, came out to be mv only. For one particle. For one particle. So I can write also impulse is equals to n times nmv. mv. That means if we are having particles of n numbers, I can write here for n number of particles. For n number of particles. So what is F average now? F average is impulse by delta t. It came out to be n mv divided by delta t. Impulse is n mv delta t. But I am not talking about inelastic, elastic, perfectly inelastic, right? Because we are doing NLM, we are not doing collision per chapter here. That's why I'm just taking these names. Okay, slowly, if I'm just taking the name of this collision type now. So if let us suppose some students are watching first time for NLM, right? They are not completed their COM, collision 1. So how they are going to grasp all these things? To get the confusion clear, now I am not taking any names. Okay. So if now second case would be if it gets reflected. Second case is case number second. Now it doesn't get stuck. It gets reflected. It gets reflected back with same velocity. What will be now my impulse? Impulse is m, v final minus v initial. M is m, final velocity will be v minus I cap minus v I cap. I can write I came out to be minus 2 mv I cap, and it is mod will be 2 mv only for one particle. For n particles, I can write it came out to be 2nmv for n number of particles. And what will be average force? Average force will be 2nmv divided by delta T. Easy? Easy, beta? Easy or super easy? Okay. Now we are having a gun problem. Third, now we are having a gun, right? A gun-like thing. Look, initially the bullet is inside the gun, and finally the bullet leaves the gun with some velocity v. So initially velocity is 0, finally velocity is v. So what is impulse? What will be impulse now? mv final minus v initial, right? I can write mv final minus v initial. Is it mv only? But from this gun, if n number of bullets are leaving, I can write n equals to n mv. I equals to n mv. So average force exerted by the gun, is it n mv divided by delta T? Is it n mv divided by delta T? Let us do a numerical now. So we are having a machine gun, and mass of bullet is given as 50 gram. Speed of bullet is given as 1000 meters per second. If n per second, number of bullets per second, if number of bullets per second is 10 only, okay, so how to find force exerted? How to find force exerted? So I can write force exerted equals to n mv divided by delta T. N divided by delta T is given as 10. I can write 10 multiplied by m. Mass is 50, but 50 gram. It is 50 10 to the power minus 3 kilogram. And VB is 1000 10 to the power 3. Cancel out. My F came out to be, my F average came out to be 500 Newton. My F came out to be 500 Newton. Done? Easy? Am I going too fast? Am I going too fast? Beta? Am I going too fast? Be responsive, no? Okay. Now, let us do a numerical, a different one now. Different one is like, if my force is equals to I cap plus root 3 j cap. I cap plus root 3 j cap. And this force is applied on a mass, and mass is 2 kilogram. What is the acceleration now? What will be the acceleration now? Okay. I guess you got some hint now. If force is given, mass is given, we have to find acceleration. So I guess we can use second law. Force is equals to mass into acceleration. So force is equals to mass into acceleration. But force is in vector form. I need to draw this thing in a what? Magnitude form. So I can write F magnitude, that will be equals to 1 square plus root 3 square under root. It came out to be 1 plus 3. That means root 4. The answer is 2. So acceleration came out to be F by m. F is 2, m is 2 meter per second square, came out to be 1 meter per second square. 1 meter per second square. Easy or super easy? Easy or super easy, beta? Huh? Easy or super easy? Yes, one is correct answer. Okay, let us do a numerical now. One more numerical. A numerical like mass is equals to 10 kilogram. Mass is 10 kilogram, right? So we are applying forces. We are applying forces. This force is 20 Newton, 50 Newton, 40 Newton, 10 Newton, 45 degree, 50 root 2 Newton. Find acceleration. Easy or super easy? This one, easy or super easy? We are having all these forces, 20 in right, 15 left, 10 in up, 14 down, and 50 root n is in northeast direction. Do it now. So how to find acceleration? Sir, acceleration is equals to force by mass, but this force should is be equals to F net, that net effect of the force. The net effect of the force. Okay? Net effect of the force. Okay. Look, if it is 50 root 2, so this side will be equals to 50 root 2 cos 45 degree. Is it 50 root 2 cos 45 is root 2 cancel out? It is 50 Newton. I can write here plus 50 Newton came out to be 70 Newton. In the same way, this figure maintains this value, no? It is 50 root 2 sine 45 degree. Sine 45 root 2, this came out to be 50. Now I will redraw the whole thing now. Here we are having 70 Newton. This side we are having 50 Newton. This side is 60 Newton. And this side we are having 40 Newton. 70, 50. So what we are having? 20. 20 in this side. 60, 40, 20. 20 in upside. 20 Newton. One equal and 90 degree forces. So F net will be from this straight line. Okay. So F net would be equals to 2F cos theta by 2. 2. F is 20 cos 45. Cos 45. Done. So answer is 20 root 2 Newton. So I can write here acceleration is force is 20 root 2 divided by mass is 10. So my acceleration came out to be 2 root 2 meter per second square. Easy or super easy? Easy or super easy? Huh? Easy or super easy? Easy? Okay, one more numerical now. This numerical will be like an object of mass 2 kilogram is placed on a smooth horizontal surface. A water jet throws water horizontally. at a rate of 2 kilogram per second with speed 20 meters per second on the object. First part, force applied by the water jet. Second part, acceleration of object. Acceleration of object. These two things we need to find out. Look, an object of mass 2 kilogram, yes, mass is 2 kilogram, is placed on a smooth horizontal surface. Done. A water jet throws water horizontally at a rate of, what this thing is, it is rate, it is dm by dt. It is 2 kilogram per second, and my v equals to 20 meters per second. So my dm by dt is changing. So how to find my force? So force is v dm by dt. V is 20 and it is 2. It is 40 Newton. It is 40 Newton. What is acceleration? Is it force by mass? Force is 40, mass is 2. So acceleration came out to be 20 meters per second square. 20 meters per second square. Done? Okay. Now let's start rocket propulsion. Let's start now rocket propulsion now. In a rocket propulsion, we are having a rocket like this, okay, and fuel is burning like this. Due to this exhaust, it gets upwards to the sky. V relative is the what? Velocity of the fuel, exhaust gas with respect to rocket. And dm by dt, it is rate of burning of fuel. So the force will be equals to v relative dm by dt. This is equals to force, and m means mass of rocket. M means mass of rocket. Mass of rocket. V relative means velocity of exhaust gas with respect to rocket. With respect to rocket. dm by dt, rate of burning of fuel. So the thrust force will be equals to v relative dm by dt. This is a force, a thrust experienced by the rocket to go up. Okay, and the rocket, if the rocket needs to go up, so my force, or I can write, look, mg is acting downwards also, right? So if my force is more than mg, it will go up. That means if my v relative dm by dt is more than mg, so my rocket could go up. The rocket will lift towards the sky. If not, then it will not go into the sky. Then it will not go into the sky. Look now, assume that rocket is going towards the space, right? And its acceleration is a. How to write the equation now? Look, this one is v relative dm by dt. This force is m into g. So I can write, sir, v relative dm by dt. minus mg equals to m times a. M times a. If no gravity, if it is flying into the space where gravity is 0, g is 0. So I can write v relative dm by dt equals to m into a. You will find numericals now from your NCERT. You will find numericals. If gravity is there, so v relative dm by dt minus mg equals to m into a. If no gravity is there, v relative dm by dt equals to m into a. Clear? If velocity is constant, if v is constant, that means a is 0. If a is 0, so ma is 0. So I can write now v relative dm by dt minus mg equals to m times a. This is 0. So I can write v relative dm by dt equals to m into g. Done? V relative dm by dt equals to m into g. So one more thing, rate of burning of fuel. Rate of burning of fuel per second is dm by dt. So after t seconds, what will be the mass of your rocket? It will be capital M, mass of rocket, minus dm by dt multiplied by that time. Each and every equation is important. If you can open your NCERT, it is written there, right? These numericals are written there. And if you open your PYQs book, you will find numericals based on these topics. Even though you will find a numerical based on this topic also. That's why I am giving you each and every numerical type so that you can tackle with the numericals. Then let us do a simple numerical. So the numerical is like, we are having a rocket mass is 600 kilogram. And v relative equals to 1000 meters per second. And velocity is constant. That means a is 0. So you need to find out dm by dt. Just find dm by dt. Okay. So I guess my equation is v relative dm by dt minus mg equals to m into a. A is 0, so this will become 0 now. So I can write v relative dm by dt is equals to m into g. Done. So v relative is 1000. Dm by dt, I need to find dm by dt. M is equals to 600, g is 10. 30 cancel out. So dm by dt equals to 6 kilogram per second. So my rocket burning the fuel with a rate of 6 kilogram per second. With 6 kilogram per second. Done, beta? One more numerical, that is, mass of rocket is given as 1000 kilogram. V relative of is given as 2000 meters per second. Acceleration is given as 5 meters per second square. Find dm by dt. Write equation. V related dm by dt minus mg equals to m into a. Done. So v relative dm by dt equals to m a plus g. So dm by dt equals to 1 divided by v relative m a plus g. 1 divided by 2000, mass is 1000, a is 5 plus 10. 0 cancel out, so we are having 1 by 2 into 15. That means 7.5 kilogram per second. 7.5 kilogram per second. Done? One more numerical. And numerical like mass of initially of rocket is equal to 2000 kilogram. Initially, the mass of rocket which contains the fuel also, that is 2000 kilogram. And if the rocket's fuel is burning at a rate of 50 kilogram per second, okay, and if the V relative is given as 20 meters per second and G is equal to 0, time is equal to 20 second, 20, what will be the acceleration part? What will be acceleration? For all these things, we need to apply the formula. Okay, formula is V relative dm by dt minus mg equals to m into a. G 0, it is 0. Now, what is V relative? What is V relative? Is it 20? Is it 20 now? 20. What is dm by dt? Is it 50? Done. M into a. I will divide by m into a. A equals to, is it 1000? Divide by mass. But what this mass is all about? Mass is equals to mass of your rocket at the time when it is burning the fuel at a rate of this much. So mass final equals to initially mass minus rate of burning of fuel in 20 seconds. Initially mass is 2000 dm by dt is 50 and it is 20. So finally the mass came out to be 1000. Done. So acceleration came out to be 1000 divided by 1000, it is 1 meter per second square. Easy or super easy? Easy or super easy? Done. Okay, now last topic of our class, that is third law of motion. Third law of motion. Third law of motion. What is third law of motion? Third law of motion states that to every action there is an equal and opposite reaction. To every action there is an equal and opposite reaction. Just like the rocket case, okay, fuel is going downwards, but the force, the fuel burning is giving a thrust to rocket to go upside. Okay, you can see equal and opposite to each other. And force and the action and reaction cannot cancel each other. Why? Because they are acting on different objects. Done, beta? Everything in the nature is in pairs. That's why in force also, that's why we are having two hands. If this hand is pushing this one hand with 2 Newton, this is also pushing this one in 2 Newton. Action and reaction. Done. So third law of motion is to every action there is an equal and opposite. So you can apply this law either if the object is at rest or in motion. You can apply this law everywhere. Okay, no time gap. No time gap between action and reaction. No time gap. There is no time gap. Okay, just like a gun. A gun, if bullet is going rightwards, leftwards, it will push the gun backwards. Done now? Clear? And third law is not important, only the second one, that impulse. And yeah, impulse is important. So you need to just take care of impulse and rocket propulsion. These two things are important. So in tomorrow's class, what we are going to discuss, we will be discussing the forces of mechanics. That means FBD. Tomorrow's class, we will be discussing FBD, right? How to find normal force, how to find different forces on a particular body. Done, beta? Tomorrow is most important class. Most important class is tomorrow. Most important. So we are going to discuss FBD, free body diagram, tomorrow. and apparent way tomorrow. These two things we are going to discuss tomorrow, right? So in this class, if you are having any issue or if you want to ask me anything, you're most welcome. If not, then I need to take a leave now because my class is already over. Okay. I hope you got everything from the class. Done, beta? If you are having any issue or anything like that, you can ask me right now. I'm the class. If not, then take care. Goodbye. Good night. So in this class, what we discussed about Newton's second law, second law of motion. Then what is impulse? Different types of impulse. M delta V, F delta T, integration F dt. Then numerical based on this thing. How to find F average, average force, then rocket propulsion. These things we done in today's class. Tomorrow we will be discussing what is weight, what is normal reaction force, okay, on inclined surface or a straight surface, horizontal one. What is apparent weight, how to find apparent weight, or if time permits, we will be discussing motion in a contact bodies. If you are having two or more than two bodies, how to find normal force F, how to find contact force between these two bodies. Okay, so for today, I guess we had discussed more than enough. So I need to take the leave now. Thank you, beta. Bye. Good night.